Bien, vamos entonces a hacer con el desarrollo de nuestra agenda en este Día Mundial del Medio Ambiente, donde engrandece nuestro Congreso, y sé que el medio ambiente y el planeta Tierra nos agradece nuestro tiempo de calidad aquí, tanto de cada uno de ustedes, un público maravilloso que nos tocó el día de ayer y un público también que sé que va a quedarse hasta el final, así como del esfuerzo de nuestros expositores locales e internacionales. Seguimos entonces con la ponencia titulada Valorización de residuos sólidos urbanos, una visión general de recursos recuperados. El expositor es el ingeniero Torsten Muller de Fraunhofer, Alemania. El doctor Muñoz me acompaña para leer la semblanza de este expositor.
Bien, movimos un poquito el polvo para que no maltrata, que son un poquito más largo, un poquito más alto. A Torsten ya ustedes también casi todos lo conocen, es un experto también de la Fundación Fraunhofer en Alemania, y tiene un título de Ingeniería en Gestión de Residuos y Tratamiento de Sitios Contaminados por la Universidad Técnica de Dresden, en Alemania también. Desde el 2010 trabaja como científico y gerente de proyectos de la Fundación Fraunhofer ICT, en el grupo de reciclaje y eficiencia de recursos. Está a cargo de proyectos financiados a nivel nacional e internacional, así como proyectos bilaterales con la industria. Su principal área de trabajo es el desarrollo de estrategias de reciclaje y sustitución de flujos de residuos domésticos e industriales, y la definición de cascadas de material para uso más eficiente de las materias primas. Así que tenemos acá a un experto en estos temas, al cual pues recibimos con un fuerte aplauso.
Buenos días a todos. Let's go with the only Spanish in my yes, good morning everybody. Today I want to focus mainly on the waste streams we separately collected in Europe, respectively in Germany, and give you some overview what we're doing with it. Anyway, those of you that have been here yesterday might know this slide, which shows more or less the legal framework we have on waste management in Europe. And today I'm going to talk about this part down here, the different waste streams we collect. Anyway, the framework is most important, because without any legal framework that organizes the collection, we barely don't have any waste management. People do just what they have. So we have different spots to focus on, a general framework that gives to the single countries the frame where to work on, like a ban on waste shipment, for example. Otherwise, you just bring it to the countries where it's the cheapest. Like a definition when waste is no waste anymore. For example, for scrap of steel or copper or aluminum, glass. A different definition of minimum standards for waste management operations, like which emissions are allowed to be retrieved from different companies, or from the process you do to ensure that there are no harmful dusts or gases or whatever, water coming from the operations you do. A definition on the product, what kind of materials you're allowed to have in the product, which is a little outside, but it's called REACH, where you ensure that there are no harmful substances in your product. So all this framework is more or less what we focus on. In Europe, it's the task of every country to implement that in your system. And the key element of all this is to collect the different waste streams. And the cleaner the waste stream is when you collect it, the higher the value is in the end of the raw materials to recover. And ideally, you really can run the materials in a closed loop. What you see here is a central collection spot for larger amounts of waste. You bring, and normally people can bring their construction waste, their broken furnitures and things like that that don't fit in the normal waste bin you have at home. And you have this organized area, not to just fill them up from the left to the right. You have a sign there written, okay, this material goes there and it goes there, and you have people watching out that you really put it in the right bin. To ensure that, for example, in the end, containers look like this, where you have on the right hand side white glass, and on the other hand side colored glass, to ensure that you don't mix and pollute, for example, transparent glass, which then can go directly back in the normal processing steps. The container you see down on the left is what you can find in most supermarkets, where you can already put your packaging material from the things you buy in the trash already at the supermarkets, as well as batteries and other things. Yes, so we have different types of collection. One is central collection, what I just explained, and the other is the individual collection already in front of your house at the curbside, which is mainly used for packaging, for normal residues, for organic fractions, which then normally goes to biogas production or composting plants. Currently there is a big discussion in Germany about this curbside collection of bulky waste, because you have it's called waste tourism from mainly Eastern Europe, like Romania, Bulgaria, where people come there and really rip up those mountains of waste, spread everything on the road, take out what they need, and of course they reuse it, but they leave quite a mess on the roads, which people don't really like. So they changed this system. It's not that you just put it on the road and someone will pick it up. Right now you have to fill a cart, put every item that is going to be collected, and then you get a date when to put it out, and they will pick it up. Thank you very much. Yes, 1 second. Air conditioning. Yes, so I just give you here a list with an overview on what we separately collect. I really like this picture because that shows you the separate collection of Christmas trees every year, which is a clean fraction. Anyway, we have a lot of different fractions that are separately collected, like batteries, light bulbs, tires, construction waste, and so on. And the following, I'm going to explain you a little bit what's going to happen with most of these fractions. I'm starting with one of my favorites, packaging. What you can see here is a lightweight packaging characterization sheet, which is describing for each different packaging. Actually, that's from a Spanish company called IMW, which is describing for each of the packaging the share in the fractions. And they have that for different areas, because it doesn't mean if you collect packaging, for example, in Madrid, doesn't mean it's going to have the same composition in the rural areas around the city. Yes, so concerning Germany, we have actually made two different ways of collecting it. One, which is mainly used in rural areas, is the yellow bag, which you normally fill up and is collected at curbside. And on the other hand, you have the valuable materials bin, which, for example, we have in Karlsruhe, where you not only put the packaging, but as well materials that are similar. Like, for example, if you have a polypropylene packaging, there's no real material difference, and there's no reason why not to put in the same bin a polypropylene basket or something like that. So that's more or less the sense behind. The main important part is that everything that you put in there is dry. So it's going to a sorting plant, and which in the end bring you out the different valuable fractions. So what is happening? PET, for example, is good recyclable as long as it's transparent, and there is a world market for this material, but as soon as it's green or blue, the value decreases. So same for other plastic fractions. As soon as you have color or other additives, it's more difficult to handle the material. And that's the key where we're, in cooperation with this company, starting to tackle. So we're setting up a scheme where the producer of the packaging has to define what kind of material he's bringing into the market, and according to the recyclability, he has to pay a fee. So the better the material is recyclable, the less he has to pay. Yes, so this picture it maybe gives you an overview and an exemplary sorting process of in a plant in different fractions. I think we're going to publish this slide, so I'm not going to read everything. And yes, so paper, you know, you collected already. Very important is as well those composite cardboard, aluminum, paper, drink bags, Tetra Pak, for example, where are specific processes to process this material, where you generate the paper, you have plastic and aluminum fractions, which more or less can be reused. Aluminum, of course, can be taken to aluminum factories, and paper and plastic, unfortunately in Germany, they're incinerated. But you can recycle this kind of material as well. Concerning the paper, every fiber of paper, every cellulose fiber has the opportunity to be recycled, and more or less 7 times you can do so. But for example, concerning the circular economy, this has a limit. The limit there is that you always have to somehow implement new fibers to keep on the quality, because with every processing step, the fibers shorten. So this is from my point of view, this is a nice example of how to where the limit is of a real circular system. So you always need some fresh material. This is something. Organic fractions are very, very, very important. I think in Latin America, it's about 50% of the general household waste amount. And that's something that is key. And from my point of view as well, the most important fraction to be collected separate, because that increases the value of all the other fractions. So what do? We have different kinds of organic material, which, for example, are garden residues or kitchen residues, or things that show up from parts, which mainly in rural areas actually most people have a compost in their garden, where they produce compost and use it again to fertilize their vegetable production in their household. In cities, we have either biogas plants or as well combusting plants where you can, that depends a little on the cities, where you can pick up normally as well for free or for a small amount the compost and take it to your households. Construction materials, the largest amount of what we have actually in Europe is like 35%. And if you pass a construction site where someone is dismantling a house, you will see that they already at the construction site make different piles. They have a pile with wood, they have a pile with metal, they have a pile with concrete and bricks. And the reason why they do that is because it goes to different treatment processes. For example, bricks are used to are used in soil remediation. Of course, they have the property to keep water. So, especially for young plants, that's really helpful to ensure that you don't have to water them every day. If you put their water, you can ensure that they will retrieve from those particles permanently water. We have a system to reintroduce sand from concrete back into concrete, which is one of the critical raw materials in this world, actually. And asphalt, which is quite common now to really rework the asphalt and bring it in back into a new road. Typical applications are as well construction of landfills. The roads in the landfills are built up from this kind of materials, or the gravel is used as well to produce drainage layers for pipes, and things like this. WEEE, what does it mean? It's waste electronic and electronic equipment. There's a law that is, the abbreviation is for that, and it means in the end all those household and consume products that are electronic, or electronically run. And over the past years, actually there has been developed a market for different parts of that. You can buy per kilogram printed circuit boards. You can trade the plastics with a certain quality, as long as they don't have, for example, halogenated flame retardants. You can buy copper cables and all that, and all that is running in very much automated separation plants. Just the first step mainly is done by hand, where people have, for example, to remove the, for example, the screen from the laptop and to remove the batteries. Where we are with the batteries, actually. If you go to Germany, I'm pretty sure it's all over Europe the same. You will find those green boxes in supermarkets. You will find in the road these kind of collection points, which is dedicated to ensure that the batteries are not ending up in the residual waste, in the household waste, or even worse, in the organic fractions. Because they contain a lot of heavy metals, and you can, if you collect them separate, you have quite easy melting processes that ensure that you can recover the metals again. This kind of material is one of the examples where we have an extended producer responsibility. What means that the producer is in charge of paying the collection and in charge to ensure that these kind of materials are really run in a circle. With the lead acid batteries from cars, it works quite well. We're there with 95-97% recycling rate. In this case, even the process is running really good. Anyway, the collection rate, especially of these small batteries, is quite low. The process is not the problem. Batteries really are the issue how to ensure that people don't just keep them in the drawers at home, but return them to the proper collection points. Light bulbs is something that can cause even bigger health issue to people. So a separate and proper collection and treatment is very important, especially for those energy-saving lamps which normally contain mercury. What you can see here is a tiny, it looks quite tiny, processing plant, but it's effective actually, processing plant for light bulbs. And this company, it's based in Italy, called Relight. They even recover the rare earth from the phosphorus powders. So to ensure that even with the rare earth there is a circle given. Unfortunately, there is no producer of rare earths in Europe, so even though we recover the powders, it's going to be shipped to China, where they will rework the material and send it back to Europe. So there are limits, unfortunately. In general, the domestic waste, there are different ways to treat it. We in Germany are big favorites, or our favorite is actually the incineration, which is easy because you don't have to sort the material, but unfortunately you lose as well a lot of value, especially in the plastic part. What happens afterwards is that down here on the right you see a slag which contains up to 20% of metal fraction in glass. So this is processed again, you retrieve the glass and you retrieve the metals. And now there are many projects running how to recover as well other potential valuable metals from this kind of fraction. Because Germany has a big issue that, or generally Europe, we have stones, we have water, and we have trees, but we don't really have raw materials left, not many at least. So we're importing a lot. So all the materials you can use from what you have at home, you should try to recover the materials, and that's what we do. We try to really use all the fractions. There are strategies, and the government gives even funding for special critical materials to recover. We love cars, as you might know. There's one of the extended producer responsibilities of cars. You have a clear defined law what kind of materials have to be taken out. You have to remove the liquids, you have to remove the tires, you have to remove fiber reinforced parts. You have shredding systems where you then automatically you can sort different fractions and they're sent to processing plants. But one of the big issues you see nowadays is on the one hand side the increasing number of electronics in the car plus the amount of batteries. There are small batteries. For example, the Porsche Cayenne has up to 50 batteries in the car. Every different type of electronics that is like the lifter of the window, whatever, is has a backup battery, and of course you need to remove them. So I would like to encourage you to take a deeper look in what you produce, take a deeper look in the materials you have at home, and even though they might seem to you be a trash, maybe someone else can make something valuable out of that instead of just throwing it on the landfill. So thank you very much. I finished with the nice picture of our institute. We run now RTART or independently with this wind power plant. In case of any question, feel free to contact me.